In example 2, we're going to use the properties of limits now. Alright, sum rule, difference rule, product rule, and so forth to help us evaluate limits. In example 2, it says you will learn in example 10 that the limit as x approaches 0 of sine x over x equals 1. Use this fact along with the limit properties to find the following limits. Alright, so we're going to do A first. The limit as x approaches 0 of x plus sine of x all over x. Now what we would really love to do is be able to plug in 0 for x and just get our limit. Unfortunately, we can't do that, because if we were to plug in 0 here for x, we would be dividing by 0. Alright, so we have to rewrite this. We're going to rewrite it using the sum rule. So the sum rule is going to allow us to write the limit like this. Okay. Alright, now x over x is 1. So this whole limit right here is going to be 1. This the limit as x approaches 0 of sine x over x, what does that equal? Well, the problem tells us that that equals 1. So we have 1 plus 1. So our limit for problem A is going to be 2. Let's do B. Alright, in B, the limit as x approaches 0 of 1 minus cosine squared of x over x squared. What's that going to give us? Well, again, we can't substitute 0 in right away because we would be dividing by 0. So what we're going to have to do is look to kind of rewrite this and break this up. The first thing I notice that up top, 1 minus cosine squared x, that's a Pythagorean identity equaling to sine squared x. So I'm going to say sine squared x over, this equals sine squared x over x squared. And the reason I make that that substitution there is because I wanted to get, it tells us that we're going to be using the limit as x approaches 0 of sine x over x for this problem. So I want to put this in terms of sine x. Alright, now we can say that we can rewrite this as the limit as x approaches 0. Alright, so we have sine squared x over x squared. So we can say that is sine x over x times sine x over x. Alright, again, why did I rewrite it like this? I want it to look like that. Now from here, we can apply the product rule and rewrite as such. Okay, so the limit as x approaches 0 of sine x over x. So this right there, that's 1. times this right here, that's going to be 1 also. So 1 times 1 is equal to 1. So for B, our limit is 1. Last one. C, the limit as x approaches 0 of the cube root of sine x over the cube root of x. The first thing I'm going to do is rewrite this as one big root. And then I'm going to apply the root rule. And so what this is saying is I can take this and basically write it inside of the root, the cube root. So I'm going to have the cube root, and inside I'm going to write the limit as x approaches 0 of sine x over x. That equals 1. So the cube root of 1 is 1. Alright, so that is our answer for C.